Hello, in this video we are going to learn what simple moving average is all about. Okay, let's get started. After I do go into full screen. Okay, there you go. Okay, so the simple moving average is another forecasting technique. Remember we had two forecasting types, the one with subjective, that's completely based on the human judgment. The second one is the objective forecasting methods, and then this is the first of the objective forecasting methods, the simple moving average. So our assumption, the main assumption here in simple moving average is that the future observations will be similar to the recent past. So if you have a data that represents similar observations, then this might be the tool and the forecasting technique for you to use. So what it does, it's very simple. That's why it's called simple moving average. So moving average for the next period, the forecast is going to be equal to the average of most recent k observations. Okay, what do I mean by that? So let's assume that our moving average forecast with k is equal to 3. It tells you that, okay, just go and check out only the most current 3 data points. That's it. Do not look at the 4th most current data point or 5th or beyond that. Okay, only focus on the 3 most current data points and then just take the average and then use it as your forecast. So as you can see, we have the monthly burglaries data here. We do have it in our Excel file. I'll switch to Excel in a minute. What do we see here is that we do have the month number in the first column, and we do have monthly burglaries in the second column. Those are the data that we had. Those are the real data. And then we do have the moving average forecasts on the third column. Okay, as you can see, we do not have any forecasts here for the first 3 months because k is equal to 3. Since we do not have the most current 3 data points for these first 3 months, we do not run moving average forecast for that. Okay, so how did I get 64 here? So that's very simple. It's just the average of D3 and D5. As you can see, D3, D5, if you take the average of it, it's going to give you 64. In other words, you just need to sum 88, 44, 60 and divide this number by 3. This is how we get it. How about 53.33? Well, it is, again, the rule is the same. K is equal to 3, so look at the most current 3 data points, right? Take the average of it, or just sum them up. Divide this number by 3. Okay? So every time a data becomes available, you have to update your forecast, right? So for example, 70 becomes available here, and then we have to update our forecast for the future period. Another important thing here is that, for example, here, this is a very important question. What is the forecast for month 54 at the end of month 44? At the end of month 44, we are right here, right? At the end of month 44, we had our 3 data points available to us, right? We are going to assume that we don't know these data points. So with the ones that we have in our hand, we are going to make a forecast for it, okay? We calculated this, 64. It is a forecast for the month, for the fifth month, right? And then it says, what is the forecast for month 54 if you are at the end of month 44? If I'm at the end of month 44, I only have these 3 data points, so therefore my forecast for the rest of the periods are going to be exactly 64 because I don't have any other data points. Well, if you have data points available to you, then you have to update definitely this measure. For example, this column updates itself all the way up to the last observation. 67.67 is just the average of this previous most current 3 data points. Okay, all right, should be very clear. Here is the graph of the monthly burglaries, the real demand. Those are represented in blue dots and also the lines. Our forecasts are represented in red squares and red lines. As you can see, we don't have any forecast for these first three guys because k is equal to 3 here, right? We start having a forecast for the months larger than 44, starting at month 45. As you can see, moving average, it lacks the trend, right? If there's a trend in this blue line, but it keeps becoming late in capturing those trends. Okay, that's one of the facts in moving average method. There are some other alternative moving average models. So for example, k is equal to 3, what you need to do, now this time you are going to take the most current 2 data points instead of 3 because k is equal to 2 here. So you have a forecast for month 44 here because now you can use only these 2. Okay? For k is equal to 3, you can use them. And we do also have a 3-period weighted moving average. I will explain what this is in the Excel file. It basically gives you the opportunity to select your weights for the time periods. So what we are assuming here when k is equal to 2 and when k is equal to 3 is that the weights for individual months are identical. So this carries a 50% weight and this carries a 50% weight under k is equal to 2. Under k is equal to 3, this month has 33.33 percentage of weight, and this month has 33.33 percentage, and this month has 33.33 percentage as well. But on 3-period weighted moving average method, you get to select the weights for the most current data points. For example, if you would like to assign a larger weight for the most current data point, you want to say, hey, 7% is going to be the weight for this. You can definitely do that. And you can say, hey, for this one, it is only going to be 20%, and for this guy, it's only going to be 10%. Then you will have to do the necessary calculations. Basically, you're going to multiply their rates with the real data points and add them up to get your forecast. Okay. See, we do have several error metrics, and in order to capture the accuracy, in order to assess how accurate your forecasting method is. The first one is mean absolute deviation. As you can see here, this is AT means our actual observation. FT is our forecast. So here the index, it shows which time period. It is T, right? Our actual observation on time period T, and FT is our forecast for time period T. So what we do is in absolute value, we take the difference, we add them up, and we divide it by n, or we just take the average, right? Because we will have the n observations. For the mean square error, you penalize this difference more, because you take it is the error in error squared divided by n. Mean absolute percentage error, with respect to actual data, how much we are deviating from the actual data. Okay, it is also the average. Alright, so let's go to our Excel file and see what we are dealing with. Alright, so here is our monthly burglaries Excel file. What do we see here is exactly what I showed you on the slide. So every time you make a forecast with k is equal to 2 and with k is equal to 3, you need to calculate the error. Error is just the difference between the actual observation, the demand minus the forecast. Okay, for each time period we do that. Those are not in absolute values here. We are going to do those right here over this section. Let me show you how 3-period weighted forecast works. So here, if you click on the formula, you will see how the calculations are being carried out. So what you see here is that I assigned, for example, 0.6 or 60% weight for the most current data point, right, which is month 44, B7, and I assigned 30% weight for the second most current data point, which is the month 43, and I assigned only 10% for the least current data point, which is in month 42. And what I do is just multiply the weights with the actual observations in these periods and add them up. That should give me my 3-period weighted forecast. Okay, so you can change these weights as much as we can. You can try different weights. But at the end of this lecture, I will show you to optimally locate what the optimal weights for these multiple time periods. Okay. Well, we do also keep track of the error for the 3-period weighted metrics and forecast. So here on this section, for moving average with k is equal to 2, I calculate AT minus FT squared in absolute value what AT minus FT is, and in also absolute value AT minus FT divided by AT. I'm going to use this in order to calculate my MAPE, use this one to calculate my MAD, and use this one to calculate my MSE. I did the same thing for MA k is equal to 3 and then 3-period weighted method. So these are the summary tables. So how did I calculate? Let's check out how I calculate MAD for k is equal to 2. So what I did is, okay, I came here, I count in the denominator, you see the count function. It basically counts how many numbers we have in this array. It just basically counts it. Whatever number you put in here, it doesn't matter. It just counts it. And remember, that's the n, right? N formula. And then we do sum those up, divide that number by this number of observations here. That's what we do. And then how we got MAD. MSE, on the other hand, it is similarly we sum these values up and divide it with the number of observations we have here, and we do the same thing for MAP. We sum these values up as shown in the formulation right here, right? We need to sum them up and then divide it by n. Okay. What is RMSE? It is just the square root of MSE. It is just a different error measure to help you decide which forecasting method is the best. Okay, so you are going to do these error calculations whenever you are proposing a new forecasting method, and based on these error measures, you are going to select the optimal forecasting technique. So for this one, we do have error values for MA moving average k is equal to 2, moving average k is equal to 3, and then 3-period weighted method. Let's try to make a decision about which one to pick. I do have the summary tables also here on my slides. Okay, let's check it out here. So if I ask you a question saying that, okay, go ahead and calculate the error metrics for your forecasting method and then give me the best one, all you have to do is to check out these error values. So when I do look at it, I see that, for example, for MAD, moving average method k is equal to 2 is the smallest. For MSE, again, this guy is the smallest. For RMSE, this guy is the smallest. And for MAPE, this guy is the smallest. Well, interestingly, moving average method with k is equal to 2 gave me the best error values. So I say go with moving average with k is equal to 2 forecasting method for your future forecasting calculations. Okay, well, keep in your mind that you have to update your values and you have to keep consistently paying attention to what's happening to your error values. You might want to switch to this or switch to this or switch to something else. Alright, here's a quick class exercise. Let's work on it together. It says that find the 4 period k is equal to 4 moving average forecast for the monthly Berkeley data, compute MAD, MSE, MAPE error metrics, and determine if this model is better than the 2 period k is equal to moving average method. Alright, so we have to switch to Excel, and it is on EX1 spreadsheet. What you see here, let me zoom in a little bit so that you can see better the selection. We do exactly have the same data, and these are the templates for you to fill in. So for the first column here that you need to fill in is the forecast column. Remember, k is equal to 4 here, so we need to use the first 4 data points in order to come up with a forecast for this guy right here. So I will just go ahead and take the average, type average, select the first 4, because k is equal to 4, that should be my forecast for this month, and I will keep doing it till this time period. Okay, these guys are going to be my forecast with k is equal to 4. Exactly, once you did fill this column, this graph updated itself, and this graph basically shows you how the real values are changing with respect to, well, how the forecasts are changing with respect to the real actual values. As you can see again, moving average method lags the trend. It's becoming late in responding to change in the real data. So you have to be very careful about how to interpret these. Okay. So the error is simply, doesn't matter whether it is actual data minus forecast, because eventually we are going to take the absolute value. Okay, so just take that. Then we have to put these guys in absolute value function, just to make sure that those are all positive. Squared errors is this squared. We go left click on that small dot on the right bottom corner and then drag it down. The formulas are going to be updated automatically. The relative errors, those are, if I'm not mistaken, absolute errors divided by the actual data points, I believe. Yes, they are. Okay. Alright, these are in percentages. And then we come here, we say, okay, how many forecasting time periods I have. I will basically either one, pick one column and then select them to see like how many observations we have forecasted for, and then MAD, remember, it is the sum of, if you type sum in parentheses, you will have to add errors in absolute value and divide this number by this guy n. Okay, that's 16.13. MSE is, you sum them up. Squared errors, sum them, and then divide this number by this n. You'll do the same thing for MAP. We'll sum this relative errors, and divide this by n. Alright, so let's compare moving average with k is equal to 2 and moving average with k is equal to 4. If you remember, moving average method with k is equal to 2 was the best one among the other three. So here we did another forecasting method with k is equal to 4. As you can see that our error measures are larger with moving average with k is equal to 4 forecasting technique. So we still need to go with moving average method with k is equal to 2. Okay? Alright. Alright, let's go back to the slides. Here is another example. I'll ask you to fill out this table. It is very simple. All you need to do, okay, here moving average, by using moving average method with k is equal to 3 and by moving average method with k is equal to 5, all you have to do is to come here. Let me see if this will work. Okay, it should. And then fill each spots here. So I'll just fill out a couple cells and then leave you the rest. So here, if you are using moving average with k is equal to 3, you need to take the most recent 3 time periods data. So here you will just need to take a 10 plus 12 plus 23 and divide this number by 3, right? Well, guess what? Your 4th month demand data became available, so you have to update your forecast. How do you do that? You include 44 this time plus 23 plus 12 divided by 3. Okay? And you will keep doing this until the last month. Well, the last month forecast, once we have 99 available, we will just say 99 plus 58 plus 37 divided by 3. Okay, so how do we do it with moving average with k is equal to 5? Again, the only thing that's going to change is the k here. So it's going to be 10 plus 12 plus 23 plus 44 plus 25 divided by 5. Okay, should be simple enough. Alright, let's summarize what we have learned so far in this video. So we learned that moving average is simple to implement, right? But there are some advantages and disadvantages of this method. It is easily understood, the first advantage, easily computed. There is no hard way of computing these forecasts. And it provides stable forecasts. Well, it's not going to surprise you, believe me, like with an outlier data or outlier forecast value. It's going to be within the ranges, so get ready for that. It might be an advantage or disadvantage depending on the case. There are also main 3 disadvantages. It requires saving all past and data points. What do I mean by that? For example, if you rely on your, let's say, the last 30 data points, you will have to keep your most current 30 data points all the time with you so that you can make a forecast for it, right? That might be considered as one disadvantage. We witnessed this. It also lags behind the trend. It's really late in responding to the drastic changes in data, so you have to keep this in your mind. And it ignores complex relationship in data. So if you have, like, say, seasonality or a cycle with a trend, moving average method may not be the best one for you. Okay, so we are going to be together with exponential smoothing in our next video. Okay, thank you.